Chapter 4 explores the relationship between mathematics, beauty, and the limits of knowledge. Begins with the observation that physics, when expressed in its most precise, is written in mathematics. Equations describe the laws of motion, the behaviour of particles, and the structure of space-time. For many scientists, this suggests that mathematics is not merely a human invention, but the language of the universe itself, timeless and universal. Yet this confidence is shaken by Gödel's Incompleteness theorem. Any mathematical system complex enough to contain arithmetic will always include true statements that cannot be proven within that system. This places limits on even our most rigorous tool. Mathematics may be indispensable, but it cannot deliver absolute completeness. This chapter therefore sets the tone. Even the most reliable methods of inquiry carry boundaries that cannot be crossed. The discussion then turns to beauty. Mathematicians and physicists have often treated beauty as a signpost to truth. Equations admired for their elegance, Maxwell's equations, Einstein's relativity, Dirac's equation, have repeatedly uncovered new dimensions of reality. Aesthetic judgment seems to offer guidance where data is sparse. The history of science is filled with appeals to harmony, proportion, and simplicity, yet beauty can mislead. Not all elegant ideas survive experimental scrutiny, and the risk remains that researchers can be seduced by symmetry or simplicity, mistaking aesthetic satisfaction for empirical truth. The debate continues. Is beauty a reliable compass or a dangerous temptation? The anthropic principle adds another layer of complexity. The constants of nature appear finely tuned for the emergence of life. Alter them slightly and stars would not ignite, atoms would not form, chemistry would collapse. Why the universe has such life-friendly values is an open question. Some argue coincidence, others necessity. Some for omnipotent deities, and still others a multiverse where countless universes exist with different constants, and we find ourselves in the rare one that supports observers. These explanations raise profound questions about meaning, and even connect observation itself to the existence of the universe. Links can be drawn to Eastern philosophy, which has long treated awareness as central rather than incidental. Symmetry provides a further thread. In physics, symmetries generate conservation laws. Conservation of energy, conservation of momentum, and charge arise directly from symmetrical principles. The standard for new symmetries has guided discoveries from the standard model of particle physics to attempts at unification through supersymmetry. Symmetry offers both aesthetic and exploratory power, suggesting that beauty is not only a matter of human taste, but embedded in the fabric of reality. The chapter then broadens beyond science to art and perception. Human beings are pattern seekers. We find beauty in proportion, rhythm, and repetition. Artists, architects, and musicians have long drawn on mathematical relationships, from Pythagorean harmonics to the golden ratio. This raises the question of whether our aesthetic sense is a reliable guide to truth or a product of evolutionary pressures. We may be drawn to symmetry because it signals health or stability, not because the universe itself is structured around it. In this sense, beauty could be a survival tool rather than a metaphysical clue. Illusion becomes the final theme. Perceptions are not transparent windows into reality, but evolved filters that simplify complexity. In the same way, mathematics models and aesthetic judgments may be powerful tools without being absolute reflections of the world. Illusions here does not mean error, but interface. Concepts like perceptions allow us to navigate reality without exhausting it. The limits of mathematics and the seductions of beauty are reminders that our ways of knowing are always partial. Chapter 4 therefore presents mathematics and beauty as twin guides, indispensable, illuminating, and deeply connected to human culture, but also as limited. They bring us close to the truth while reminding us that reality exceeds both equations and aesthetics. The chapter closes by suggesting that science and art alike circle a mystery that remains beyond capture, and the recognising limits may itself be a step towards deeper understanding. So this is part 31 in the video series, and we're now on chapter 4, Mathematics, Beauty and Limits. So we've been told that mathematics is the one thing we can trust, the solid ground beneath everything else. But even mathematics contain truths it cannot prove. The deeper you push logic, the stranger it becomes. What if certainty itself is impossible, even in mathematics? So we're on to section 28 in the book, Mathematics is Fundamental, Gödel's Incompleteness Theorem and the Edges of Rigour. So physics keeps pointing us back to mathematics. Strip away the talk of forces, particles, waves or space-time, and underneath it always equations. Elegant symmetries, hidden geometries, abstract patterns that somehow appear to capture the behaviour of the real world to absurd levels of accuracy. Mathematics may not be considered to be just a tool here. It can look like the language of reality itself. That's why so many physicists secretly worship maths. It's clean, logical, rigorous. No vibes, no feelings. Arguable, but hopefully you get the point. No fuzzy words. If you can prove it, it stands. 2 plus 2 is always 4. Pythagorean theorem doesn't wobble with mood. Maths seems eternal and objective in a way nothing else is. Some go as far to say the universe is mathematics, and what we call space-time and matter are just shadows of deeper mathematical structures, so something called a Platonic universe. Here's the twist. Even mathematics, the thing we take as rock-solid foundation, has its cracks. That's where Gödel's incompleteness theorem comes in. In the 1930s, Gödel proved something shocking. Any consistent mathematical system, complex enough to include arithmetic, will contain true statements that can't be proven within the system itself. In other words, there are always truths that lie beyond proof. You can't build a system that's both complete and consistent. That's devastating if you wanted mathematics to be the ultimate bedrock. It means there will never be a final set of axioms from which all truths can be derived. There's always an edge you can't cross. Even the most rigorous tool we have carries built-in uncertainty. This part ties back into the bigger themes we've been tracing. Physics, as rigorous as it gets, still leaves gaps, like consciousness or how to unify quantum mechanics and relativity. Evolution gives us survival maps, not truth. Ethics looks binding, but may just be a social hack, and we'll cover that in section 34. Free will feels real, but slips away under scrutiny. Cover that in section 35. Even mathematics, our supposedly perfect language, turns out to have limits baked in. The point isn't despair, it's humility. Every system we build to explain reality runs into edges where certainty fails. Illusion isn't just in perception, it's in the very structures we use to make the sense of things. The fact that maths both describes reality so well and collapses into incompleteness at its core mirrors our situation. We can model the world with incredible accuracy, but we still can't explain why anything exists, or why we feel like something to be alive. So mathematics is fundamental, yes. It's rigorous, yes. But it also shows us that rigour alone won't crack the riddle. Even in the purest logic, mystery remains. That's the perfect seg into everything we've been circling. Physics, perception, consciousness. The closer you get to bedrock, the more it slips through your fingers. Mathematics is far more powerful than we imagined, but not all powerful. And if that's true, then no system of knowledge can completely explain itself from within. Which means the problem isn't just finding the right theory. You might be expecting reality to fit inside any theory at all. So are the limits we keep finding in reality actually limits of reality, or limits of us? Next up, we're still in chapter 4, Mathematics, Beauty and Limits, and we will cover section 29, which is the beauty of mathematics. Does elegance point to truth?